So without further ado, I'm going to introduce our next speaker, Jaromir. He's a senior threat researcher for Trend Micro, specializing in tracking and reverse engineering threats, such as APTs, DDoS botnets, balancing banking Trojans, click fraud, and ransomware that target both Windows and Linux. Without further ado, take it away.
Okay, thank you for introduction. So today my presentation will be about electron-based applications abused in targeted attacks. So in short, this will be the outline of today's presentation. So I will introduce the Electron framework, talk about a few methods how threat actors have abused these applications, and at the end there will be like 3 cases of 3 concrete applications which have been abused and which we have seen in the wild. So now let's go for the introduction. What is the Electron framework? It's like open source project. It's like the tool, or it's the framework in which the developers can develop their application, and they used web developing languages like JavaScript, HTML, and CSS. In this framework, the developer has just one code base, and they can build very simply just by one command this project to be able to run on different platforms, on macOS, and Linux, and Windows, which I will talk a little bit. I will show you the process in the other section of the presentation. The Electron projects, Electron applications, they embed Chromium and Node.js into their binaries. So basically, Node.js is the server-side JavaScript runtime environment. It's like asynchronous, event-driven. It implements or it embeds the Node package manager, so the developer can use many developed or many prepared packages for their development. For the process architecture, the Electron presentation use or inherit Chromium multiprocess architecture, which means that there are like several different processes. There is like one main process, which is the only one, and it is responsible for application entry point. It runs the Node.js environment. It creates and manages the application windows. It controls application lifecycle, so when the application is created, when window is launched, when application quits, and so on. And it can interact with operating system via API. Then there are few renderer processes which can spawn like one window for each browser window class, and also these processes are responsible for rendering web content. So if you execute or if you compile and run the Electron project, you can see like in the screenshot there are like several different processes, one main process, and there are additional processes like these renderer processes I mentioned before, the GPU process for graphics, and also some utility processes which have access to networking or some other capabilities. Electron framework is very popular, so hundreds of applications have been developed with it, and these are the icons of the very known applications like GitHub Desktop, communication tools like Discord, Signal, Skype, WhatsApp, Teams, Slack, Visual Studio Code, and many others. So a little bit overview of the Electron project is like what it is from developer point of view. So if you want to develop like very simple Electron Hello World application, if you follow the tutorial, you edit at least these 4 files. There is package.json file. So this file contains some metadata. It contains the application entry point, the author, dependencies, and so on. Then there is one HTML file which contains the template of the website, which will be displayed in the application window. Then there is main.js file. It is the main kind of entry point file, which is responsible for creating browser windows, like here, like creates the browser window class. A little bit later, it loads the website template, the previously shown index.html file. Later, there are this script contains the code responsible for some events, like when application is ready, when application is activated, when windows are closed. So these are the actions which which will be like handled in the script. And there is like one more important thing. There is this thing called preload.js, and there is some code which is executed in the renderer process before the main website template is loaded. And this script has like more capabilities. It has the access to Node.js API. So for some security reason, there is like this the context of this main script and this preload script are like separated. So when you edit all these files, the directory structure looks something like that. Now you need to build and package these files. So for something like this, for this task, you use, for example, a tool called Electron-Builder or some others, and you run very simple script, npx node package execute. Electron-Builder is the tool for packaging and building the project, -m for macOS, W, Windows, L, Linux, and then building process starts. So here, this tool packages your application for platform Darwin, which is macOS, and output directories, output formats are, for example, macOS zip file, macOS DMG Apple image disk, then for Linux, snap or app image format, and for Windows platform, nsys, nullsoft installer, and executable file. So just one command, and you get like 5 different packages for 3 different architectures. So when you see this Hello World application, this is the result. The upper one running on macOS, the lower one running on the Windows. So basically, the result is basically the same. After compiling the application, like if you are like a researcher or a reverse engineer, and look into the files which are like embedded inside these packages, you can notice some file with extension ASAR, ASAR, which stands for Atom Shell Archive Format, and this is some special format for storing the source code of your project. So in this ASAR archive, if you open it in hex editor, you can see something like that. So in the beginning, they're like in binary, they're like some length of the file, followed by JSON object, and this JSON object contains the files where there's the list of files, starting with the file name, the size of the file, and offset and location inside of the file. So these ASAR archives are usually found in resources directory in all these different formats I mentioned before. So if you need to edit this ASAR archive or extract the sources, you can use some of these commands which are part of like Node.js. So by calling npx asar extract or extract files, or if you don't want to have Node.js, you can download and install 7-zip plugins, and basically this ASAR archive can behave like normal archives. There is also like this WinASAR utility, which is like special tool just for extracting this. So we have seen like in the wild, like threat actor basically abusing like these electron-based applications. And there was like very interesting talk or very interesting presentation in Black Hat USA 2022 called Electrovolt Pawning Modular Desktop Apps While Uncovering New Attack Surface on Electron. So in this presentation, the researchers talk about basically like 3 security features. One of them is node integration, so whether the access to Node.js resources is available or accessible within the renderer process or not. Then there is context isolation, so this is the isolation between this preload.js and the website, as I mentioned before. And also the feature is sandboxing, whether the sandboxing, the application is enabled or not. And in this presentation, like the researchers talk about like many different applications and several different vulnerabilities. In the wild, we have noticed only very similar case to the second one. When there is this vulnerability, CVE 2021-21220, It has been exploited by threat actors in the wild. It applies to this older version of Chromium, before the version is 89 dot something. The code or the Chromium is vulnerable only when the sandboxing is disabled, and the source codes of this vulnerability are available online. So you can search for proof of concept source codes. You can edit the source code like this. So in this repository, all the threat actor needs to do is just to find this shellcode variable, replace the content of the shellcode, and run it. And the second case, or second way of abusing Electron-based application, which we noticed, is the directly patching the existing applications, either by exploiting the vulnerabilities, like in the previous case, or just in case, or the another case is when the threat actors have access to the build environment. So basically, they just modify, they just replace app.asar archive with a malicious one. So for this purpose, they can use this kind of script, which we have seen in the wild, PowerShell script, where in the beginning, threat actor checks the size of the app.asar archive. If the size matches doesn't match any of these defined sizes, they set this particular variable, and later download file where they download ASAR archive from a malicious website and replace the app.asar archive in the resources directory. Or they can use, again, another PowerShell code where the script works as a patcher, where the script searches for these substrings and replaces them with another strings. So in this case, you can see, for example, in the first and second case, there is something like auto updater, which is disabled or commented out in the patched version. And on the line 4, the URL address is replaced with the malicious one. Now I will shortly talk about few selected APT cases which we have investigated in the past. These are Iron Tiger and the application called Mimi Secure Chat. There's another actor with Com and Live Help customer engagement platform applications. And the third one is Labbu threat actor and abusing the Metia live chat application. So in the beginning, I will talk about this Mimi secure chat application, which is the multi-platform chat application. It comes from the Chinese language where Mimi means secret. And this application is available for macOS and Windows as the desktop versions. And these versions or these applications have been Trojanized for some time in the past. The application also offers Android and iPhone versions, but these versions have not been, or we haven't observed them to be modified. So as researchers, we usually look for this app.asar archive, and inside this Mimi secure chat application, we notice or we find this electron-main.js file. And inside of this file, we noticed this kind of code started with eval function packed, which is the marker of Dean Edwards JavaScript packer. So this is the packer which has some online tool for compressing your code. So you can enter very simple code, click on pack. After packing, you get like this obfuscated version of your code. The deobfuscation is quite easy. So after the deobfuscation of the previously shown code, we get something like this. It's like the downloader, which checks the platform, hard-coded IP address, and below there are like 3 different files, one executable, DLL, and binary code, which leads to this Hyperbro downloader, which is like some custom backdoor run by Iron Tiger threat actor. For macOS version, it's very similar. Testing checks platform, Darwin macOS, IP address, downloads the file, makes it executable, and runs it. During our investigation, we noticed like this interesting situation. when one day we downloaded the file, which is the left screenshot, and we didn't notice any malicious modification. Downloading about like 2 hours later, we downloaded the same file from the same URL, and we noticed that electron-main.js had different size and different modification time. So it looks like the threat actor had access to the backend, to build environment, and they modified the application when the new version was published. Also, this application, for some reason, displayed a few security warnings. The reason is that the installers were unsigned and developers for macOS unverified. On Windows, it displayed one warning. On macOS, 1, 2, 3 warnings, and it also needed like more like interaction from the end user, but still, the attack was successful. Last slide about MimiChat. Like in our telemetry, we have found like this, like interesting requests. Then we had one malicious domain, and from another domain, we found get script.js and post script.php. We managed to get the source code of script.js, and it was a custom JavaScript password grabber. And this subdomain, .domain, from which this request was made, was an authentication portal for some development tool. So the developer connects to this authentication portal. This authentication portal was likely compromised, and the script, the stealer script, exfiltrated the developer's credentials, and this is probably the way, or it's possible that this is the way how the whole thing started. Now I will talk about the second case, or the second application. These are the Com and Live Help customer engagement platforms. So again, this attack was active for some time, and just to explain what these platforms are, is that when someone has the website and wants to provide chat with the customer, so the website operator runs this kind of agent console in some of his machines, and then inside the website, he embeds this kind of widget. And when a visitor of the website clicks on the widget and registers, this kind of chat window appears there. So visitor of the website uses this window on the right to communicate, and the website like owner uses this agent to communicate with this customer. So in this case, this agent application was the one written in Electron.js, and it was compromised for some time. So in this case, we had the Trojanized desktop application, which loads some JavaScript, which then drops legitimate executable file with sideloading vulnerability, which loads decryptor, which decrypts and loads the first stage of the attack, which then downloads and loads the second stage, which then downloads and runs several or some of following plugins, or it can update itself to the newer version. So when analyzing this file, so again, we search in app.asar archive. There is file main.js, and in the end of the main.js, you can see this kind of suspicious code with long hexadecimal string. So after beautifying the code, you can see that there is some encryption. This encryption or decryption decrypts the URL address. Then it connects to the CNC server and executes the code via eval. The decryption is very simple. It's the XOR. So here you can see encrypted string, and below is the decrypted string, and here is key for decryption. The backdoor has like many different functions. So here is the example of collecting operating system information. So when it takes the fingerprint, lists tasks, gets host name, username. Then the backdoor function has the ability to run the code. It can run either JavaScript code, or in this case, it uses cmd.exe to run like operating system commands. The second stage of the script, it can be responsible for maybe additional trojanizing or modifying the original application, or it drops additional malicious files, which are the native files. Because here, in these variables, you can see the marker 4D5A90, which is MZ marker for executable file. And later, again, there are like 3 files, one executable, one DLL, and binary file with encrypted content. And the last application I will talk about is this Meitia live chat application. So it looks like very similar to the previous case. Again, website with a widget with this icon. After clicking on this icon, the visitor of the website opens the window with which it can communicate with the website owner via chat. So we found that the application which is used for this sort of communication have been like exploited, and we found like this case by finding like one Cobalt Strike sample which was related to a campaign stealing cryptocurrencies, and this campaign used one online code repository which made a reference to this Meitia application. So we had access to the repository, we downloaded all the files, and inside of this repository, we have found something like this. We find the HTML code, in title is the reference to Meitia application. Below, it downloads like some picture, which will be displayed on this web page. Then some typos quoting domain where letter L or letter I is changed to L. So basically, the infection vector is that the threat actor sends the exploit through this live chat box, and it appears, or visually it appears like this kind of screenshot for some withdrawal of crypto funds. But this is not a picture, it's just HTML file which displays this picture, and in the background there is the exploit. This exploit worked for older version of the application because these older version of applications, they displayed or they rendered the content by the command load URL, and they loaded the content inside the application. And also the older applications did not use the sandboxing, so the sandboxing was disabled. So in older applications were vulnerable. However, in the newer versions, probably also the developer of the application noticed this, and they put into the code the following comment. For security reasons, all links are opened through external browser. So the links are not rendered inside in the newer applications. They are rendered in the external browser, like Firefox, Chrome, or whatever else, which usually or which always use sandboxing. So this makes it not vulnerable anymore to this attack. So we have the targeted Electron application. The threat actor sends the malicious link. The application then, if the user behind clicks on the link, then the application loads the code from code repository, loads exploit, exploit executes the shellcode. Shellcode is Cobalt Strike stager, which runs batch commands, which then patch the Electron application, which then delivers additional JavaScript payloads. So the scripts can be either batch or PowerShell scripts, and they patch Meitia application either by downloading and replacing this app.asar archive or patching like one of these JavaScript files inside. So the patches or the modifications can include, for example, replacing the URL address to some malicious one, or to some not official one, or they monitor the event here for creating new window, and when the new window is created, then it executes additional JavaScript code, and this JavaScript code is loaded here from one of these malicious domains, which is controlled by attackers. And one more script I would like to mention, we also found in this repository, which we had access to. It was the script for grabbing credentials and stealing cookies. So the script, in the beginning, it checks the title of the page. This in Chinese, Denglu, means login. So when the victim is on the login page, then by calling get element by ID and element name, email, and password, so the content entered into these two elements are stolen, and they are exfiltrated here to a domain which has some kind of, again, typo squatting or kind of similar content, which is controlled by attackers. So now we are coming to the conclusion. So the Electron applications are usually very big projects. They contain many files. Then there is this app.asar archive, which contains also many more files packed into one file. So if you are like threat researcher, it's always a good idea to check the JavaScript files inside the archive. If there are any modifications, any obfuscated code, which might be suspicious. We have seen that these applications are quite popular, and they have been like abused in some of these supply chain attacks, and these supply chain attacks are very successful. So in case of the previous application, in this in one of the applications I told you, or I've shown before, even if the operating system shows many different warnings, the users still keep ignoring them and get infected. All the threat actors are quite advanced. They have like good technical capabilities. They have good understanding of the environment. They use Electron applications to serve as downloaders of droppers of additional malware. So their downloaders or droppers are in JavaScript, but usually additional malware, which is then downloaded or dropped, are the native malwares. And the malware runs on all different platforms, and the threat actor, the first two threat actors are interested in espionage or stealing some data, files, and information, and the last threat actor I talked about had the financial motivation. So these are few blog posts I co-authored like last year. So if you wanted to know more about these cases, there's like much more content. So please have a look like at any of these blog posts. You can find it easily on our blog post. And basically that's all about my presentation. So if you want to ask questions either now or you can meet me later, I'll be here the whole week.